Okay, so we have this problem here called Discord dilemma, and we're going to solve it today. So essentially what this problem is we're on a Discord server, and we have a nickname on this Discord server. We decide to change it to 0 in hopes of getting to the top of the server list that's on the right of the Discord server. So server list like this, right? And when we change our nickname to 0, we get moved up above everyone else who has the same role as us. However, there are still people who have roles that are above ours. And this problem gives us log on and log off events of people with certain roles. And it also gives us events where we get a role added to us and roles get removed from us. So the goal of this problem is to, after each query here, after somebody logs on, someone logs off, we get a role added to us, we get a role removed from us, output how much people are in front of us on the server list. So let's say there is maybe an admin online, one admin online, and we have the role next to us, just let's say everyone, and there's some people online, 2 people, and this is us. This is us right here. So there's 1 person in front of us, and that's what we output. We output 1 because there's 1 person in front of us. So that's how input output looks like. Now, the trick in this problem is that there's 300,000 queries, which is 3 times 10 to the 5. And we have 30 cases, and 300,000 is 3 times 10 to the 5. This combines to be 9 times 10 to the 6. Now, we also have to do something per query. So for every query, we have to do something. And if we could do these queries in constant time, then this should run in time. However, that is not the case. So we have, they're giving us n, the amount of roles, 100,000 at max, q, the amount of queries, 300,000 at max, and r, the amount of roles that we can have, the amount of roles that we currently have, which is less than n, because n is the amount of roles. So less than or equal to. And what we have to do per query is, when we check that someone's online, let's imagine we had an array of 100,000 elements, or n elements. N is the amount of roles. And someone logs online, right? Let's say this is filled with zeros. Someone with the highest role logs online. We just change this to 1. And they log offline, we remove 1 from this, change this back to 0. So these operations are over 1. But what about these role operations? Let's say we currently have this role, right? If we get this role removed from us and get put here, or sorry, that's not a good example, and we get put here, we have to calculate every single role here. So we have to look and iterate through this entire list, checking how many people are in front of us again. So that takes O of n, n being at maximum somewhere near 100,000. So even if these queries are split up evenly, where we have to search through 100,000, not that much, our time complexity is still looking like times 10 to the 5 here, because times 100,000 for each query. And this is 9 times 10 to the 11, and this is very close to 10 to the 12. 10 to the 12 is a trillion. Definitely not good for a program, which, if it exceeds a billion, usually times out. But this is just like an estimate of worst time complexity. And if it's anywhere near this, it won't run in time. So obviously this cannot be our approach to solving this problem. So what should we do? Well, we can make a segment tree. segment tree is the approach to solving this problem. Now, let me quickly go over how the segment tree would look like. So we'd have a binary tree right here, right? Let's imagine we have 4 roles. Index from 0. We have these nodes. And at the bottom, everything is 0 at first. Here is 0, 0, 0, 0. And what we need to know is, let's say we had this role, right? We want to figure out exactly how much people are in front of us, right? So let's say we had this role, right? And we want to find out how many people are in front of us here. If, let's say we added these two together and put it into here, we could just access this and know exactly how much people are in front of us. So it changes the time complexity to log n, making things a lot faster. Let me give more of a real example. Let's say there were 90 people online, 45 people online between roles 0 and 1, and there was 15 people online in role 0, 30 people online in role 1, 45 people online in roles 2 to 3, 40 people online in role 2, and 5 people online in role 3. So let's say we had role 3. Alright? What would happen is that we're above everyone in this role. But now we have to find these people. How many people are here in all these things? So we would just search, okay, well, we want to find 0 to 2. And 0 to 2 does not completely overlap this. In fact, this gets overlapped by this. So we have to go down both paths. So now we are searching here and here. So now what we do is here we see that 0 to 2 completely overlaps 0 to 1. So let's say we had a resolution variable, and we just add whatever the sums in here is, 45 to it, and we're good. We could end this section. Now here we have 2 to 3, and 0 to 2 partially overlaps that. So we have to search both here, and it searches here. 0 to 2 completely overlaps 2, so we add 40, and 0 to 2 does not overlap 3, so we return 0, and that's 0, nothing. And this would give us the total amount of people in front of us. So let me show you another example where maybe we wanted to query 0 to 1, right? 0 to 1, we would search both people here because this partially overlaps, and here we see that nothing overlaps, so we return 0, and here we see that it completely overlaps, so we return 45, and our resolution is 45. But when would we look for 0 to 1? When we had role 2, because we know we were above everyone in role 2, so these are the people in front of us. Now this may not look like a big time save, it kind of looks like it's still the same time complexity, but when we scale this, it gets a lot better, a lot faster than regular querying. So let's code it up and let's code a solution to this. So first let's take a look at input. So we're going to be taking amount of test cases. N is the amount of roles, Q is the amount of queries, and R is the amount of current roles we have. So here we have amount of cases, 2, 3 roles, 8 queries, and we have 0 roles currently. That's why this blank line is here. So then we have the 8 queries, and then we have another test case where we have 6 roles. Oh, sorry, there's 6 roles on the server, 7 queries, and we have 6 roles, which is right here. And then we do the thing again, and we check the sample input. So let's start off by coding it, or coding the input, right? Okay. Now we're going to want to make a buffered reader to read input. Now if you're used to using scanner in Java, not buffered reader, this is basically just fast IO, fast input, output, and it reads the same thing. It reads the entire line as a string. So new input stream reader system.in, and then string tokenizer. What this does is, because the buffered reader just returns an entire string, we gotta tokenize it, so separated by spaces, and this is what the string tokenizer does. So line. Now we can take input. But first line of input, it's just the test cases, right? It's test cases. So we can just write int c is equal to integer.parseInt br.readLine. Then next we have to do this because it's going to be split up 380. So we could get roles integer.parseInt st.next token. Then we want queries. Token. Let's call these current roles n. ParseInt st.next token. And let's call those roles n, representing how much roles we have. That's why the n at the end. Okay. Now before we move on, let's create the segment tree. Straight up, right? So let's first make a node, a class in here. So let's make a seg node. And what are we gonna want from, no public. Yeah. And what are we gonna want from this seg node? So what we're gonna need is we're gonna need the starting point. So as like the node at the top of this tree had, its starting point 0 to 1. So what it represents, how much of the list it represents, the value inside of it, and its children. So we're gonna want an int start end, int value, and we're gonna want a seg node right and left. Then we'll make a constructor where we have public seg node, and we want to give it its start, its end, and its value. And I believe right and left are assigned later. Yeah, that's how it's gonna be. So this dot start is equal to start. This dot end is equal to end. This dot value is equal to value. And we'll see in a moment. So now we want another class called segTree. So this segTree class, what it's gonna have, it's gonna have a starting a node, so seg node root. Then it's gonna have a build function to build the segment tree. So it's gonna return seg node build tree, and I don't know the inputs yet. I'll figure that out later. It's gonna have a query function. I don't know the return type yet. I'll figure that out later. So first, let's make the constructor. So public seg tree int start. Oops, sorry. Let's pass in the array that we want. So it's called roles, right? And let's just assign root to equal build tree. And what do we want passed into build tree? We want the start of the array, start, int end, int value. Oh, hold on, I think the actual array the start and end of the array, because this is recursive. So roles 0 roles dot length minus 1. Uh-oh. Oh, this is a period, not a comma. Okay. So now, what happens here is we're gonna wanna iterate through this tree until we reach a point where start and end are the same. So start and end currently are the entire size of the list, right? So let's say there's 2 things in this list, right? We split them up into 0 and 1, and when they're individual values, when start and end are the same thing, right? So start and end are 0 and start and end are 1 here, then we know we're at the bottom of the tree, and we could just put in the values, and then we could propagate upwards. So if start equals end, then what we can do is return new segnode. The start being start, the end being end, and the value being 0, because as we said, I believe this problem starts with all people being offline. Okay, next, down here, so we could put this to 1 line. Down here, we can make it so that a new segnode is created. So segnode node, sure, and this is made into a new segnode. We have the start, end, and value, and then we could build the right and midpoint. We have to make a midpoint between these. Start plus end divided by 2, and integer division should round it down for us. And then we build tree by making the start to the middle minus 1, and for the left we make, oh sorry, this is supposed to be left, this is supposed to be right. Build tree array mid plus 1, no, mid to end, yeah. Okay, so this is how it ends up going, and then I believe we just return node, if I'm not mistaken, because now what happens is, in this small example, we have 0 to 1 and the array, and oh wait, why are we passing in the array? Yeah, we don't need the array in this case, because it's just start and end, and we're always passing in 0 because the array has nothing in it, so we don't need it. Yeah, okay. So now this builds the tree. We have all the nodes that we need, and a 0 0, and we don't need to propagate anything upward because, well, yeah, because if we did, we'd just be, what would we do? Node.value is equal to node.left plus node.right. Yeah, something like this. So see, these are built fully. Dot value. Let's just leave this. So these are built fully, and when we get down here, it'll propagate back upward, and this will go here, this will go here after these complete, and then this value plus this value is equal to this value, and that's how it goes up. So what we're gonna want to do is make the query function. So query is just searching for the thing in the tree. So I don't believe we're returning a segnode, we're returning a value of an integer. So query tree. we just write the start and end point we want to query. So for example, in querying in this case, we'd have the Discord role values and we're searching for them, right? So querying would actually be finding the start and end point. So for example, this, so we're querying from 0 to 1, we'd find this value and then we return it. So how we do that is we find the mid of this again, start plus end, divided by 2, and then if, yeah, we do a bunch of conditionals. So if start is greater than root dot, start is greater than root dot end, or end is less than root dot start, we could just return 0. Because this means that, let's say start is 5, right? And we're searching 0 to 1. Start is 5, end is guaranteed to be greater than start. It's greater than its end. So we know that it's out of bounds already. So we could return 0. Now otherwise, if start is less than or equal to root dot end, and less than or equal to root dot start, and end is greater than or equal to root dot end, we know that we could just return the value because it's, or, oh wait, hold on. Yeah, we're gonna need to pass in the next element for a query. So the next node in the query, of the root, to query the next segment of this tree. So let's actually make a builder function here. So we could just write query. It's gonna take the int start, int end. It's gonna call query tree. It's gonna return query tree. Return, and it's gonna pass in root into query tree. Query tree needs a seg node. Oh yeah, okay. And finally, I believe we just, if it doesn't get any of these, we just go both ways. So, oh, we don't need mid. Oops. Return query tree, node dot right plus query tree, query tree node dot, I don't know why I keep doing that, left and then right, not right and then left. It doesn't really matter, but it's just bothering me. Alright, okay, this should be our query function. Not too complicated. And then we need our update function. So what this should do right here is it should go from the start of the tree, and it should find what we need to find. Then we need the update function, update tree. It should also take a seg node, int start, int end. At this point we're updating trees at one value, so if somebody logs on with a role, we just have to go down to the role, and yeah. So in this case we can actually just put their update position, and if is greater than node dot end, or update position is less than node dot start, then you can return return. This doesn't have a return type. It should be void because it updates this tree in this class. Then if the update position overlaps partially, overlaps fully, so update position is equal to root.start, and update position is equal to root.end, then we can make node.value. Oh yes, sorry. We need, not only that, we need the value that we're updating it with, value, and then we need to make the update function for the user for simplification, because they don't have access to the node. The node is the root. So int update position and int value, and then they could just call update tree with root, update pos, and value. Perfect. Yeah. And this would make node.value equal to, what is it? It makes node.value equal to plus equal value. There you go. And then we return. And then value plus equal, node.value is going to equal to the update tree of node.left, update position, plus update tree node.right. And I think this is it. This is our segment tree. I don't know why it's giving me an error. Oh my god. Alright, hold on, wait. Yeah, no, oh, sorry. Okay. We do it like this, and then at the bottom here, node.value is equal to node.left.value plus node.right.value. Like we would have had it right here, but this is not needed here, that's why I commented out, because everything is 0 at the bottom. I think this should be good. I think this is our segment tree. Yeah, that took a while. But this is a segment tree. I really hope this works. If it doesn't, that's so bad. Oh, something also. We don't even need this roles thing if they all start with 0, and we don't need an array of roles if we have the segment tree. So we don't need to pass in the roles here, because we just need to pass in the length. And the thing is, they give us the amount of roles, right? They say that there is, what, 3 roles here, right? That's, those roles are roles 1, 2, and 3. However, there's also a 4th role, which they don't tell us, which is the add everyone role. So these are roles in the server, and then there's the add everyone role. So now we could have a seg tree. Tree is equal to new seg tree. Roles n. Boom. Alright. Now let's just test it. Let's say we had seg.tree.update queries. Wait, what? It's update position, no? Oh, it autofilled. Oh, so we want to update position 2 with 5. We want to update position 0 with 3. We want to update position 5 with 9. And then what we want to do is we want to query from 0 to 2, and this should return 8. Ah. Please? Oh, what did I do? I forgot a semicolon. Thank you, compiler. Okay, what were inputs? Test cases 1. Roles, let's say 8. Queries. Oh, it doesn't read anything yet, so these don't matter. 1, 2. Ah. Keeps going. Done. It should happen because mid keeps going down by 1. Maybe something is happening where 0 to 1, right? To 0 and then minus 1. There we go. Why did this happen? I don't know. Okay, well now I know the issue. It's because the mid is being messed up. Oh, I think if we just do this, this should fix it because the mid only goes down by integer division. So maybe let's pray. 8 0 0 because these don't matter. Wait, first case 8 0 0. Very very cool. Right equals null and left equals null. Left equals null and right equals null. I completely blanked my mind that I had to set those to null here. And if this works, this is gonna be kinda 8 0 0. What? Okay. After being a bit blind, I just realized that these are root, not node, which is not the okay. I see guys. Right. I don't know why that happened. I made an oversight like that. Oh my god. What the? Okay. I'm now confident. Yeah, look at this. Look at this. Look at this. Why would I? Oh my god. What? Why would I write root? I wrote root everywhere instead of node. I can't believe that. I bet like everyone who's watching this saw that. It's 8, right? 8 is right. Nine plus 3 plus 5 is 17, yeah. Cool. Good stuff. Okay. We have the segment tree. That took a while. Hopefully I cut off enough of the video to still make it entertaining. I don't know. I don't think I'd have enough content to cut. Our first line of input will contain a single positive integer. Okay, so next we just need to do the problem as is with the segment tree. So whenever we need to update something, we could update it. Whenever we need to take a roll off, we just need to track the current roles we have. So the next line of input we have is the current roles. So we have, we can make a priority queue of PQ equals new priority queue of integers. These integers representing our roles. PQ.add n for the everyone role, because we always have a role. Roles n. And then we need to reset the string tokenizer for the new line of input. And then we go while current roles n I++, and then pq.add integer.parseInt st.nextToken. And on top of that, we also want to make, because they're going to be removing our roles and adding roles to us, and it doesn't say it says if it wasn't there before. So they could say that they're gonna add a role to us that we already have, or remove a role from us that we don't have. So we're gonna have to track what roles we have, what roles we don't have, because we have them in this priority queue to make this faster. To get basically the priority queue, as we put elements in it, they're already going to be sorted, so we know the best role we have at any given moment. And then when we remove a role from us, we can just say role tracker. Role tracker equals new int equals n. So we have, what is it, 0 to, yeah. All these have to be subtracted by 1, because they're starting from the first index and we want them to start from the last index. They also, all of these have to also be added to the role tracker. So we need to grab this, make this int role, and then role tracker and role equal to, let's make a few constants real quick. Equal has role. Now cool, we have our list of roles, and now come the queries. So we know how much queries we have. Oh, also C. So while C is the amount of cases, C minus minus is greater than 0. Just do that. This must be an hour video by now, for real. Okay, now we have to look through all the queries, so we're gonna have to start taking them as input. So for int I is equal to 0, I is less than queries, I plus plus, or we reset our string tokenizer so we could take the input. We're gonna have, if A, it starts with A and B, we're gonna get people with highest role X log on. So we're getting people with role X and how many people log on. And in the other case scenario, we get a role added to us or removed from us. So we're always gonna have our type, so string type, we can just make it a string, right? St the next token. Int role, integer dot %, st that next token minus 1, and then we make a switch to type, check if it's A, otherwise we can break, and if it's A or B, we also have to take the amount of people that get on. So people equals integer dot %, st that next token. We can make people up here. We could assign it here. In the case of either of these queries, we have to get the amount of people that are getting online or offline. And C and D we're already fine. We have to have the highest role we currently have. So let's add that on. Oh, yeah. We could put that here. So int highest best role is equal to pq.peak. It takes the, this is all our current roles, we'll grab from the priority queue and get the best role that we have, since it sorted our roles in order of smallest to largest. Smallest being 0 and largest being n, and the smaller the roll, the smaller the number, the better the roll, the higher up on the server list it is. We'll just go at this bottom here and say tree.query from 0 to the best roll minus 1. If we have roll tracker at roll is equal to default config, which means they don't have anything. So we need to add pq.add roll. If roll tracker at roll is equal to set for removal, then we make equal to has roll, because it was set for removal. We have pq.add roll, and if best roll, I'm sorry, less than best roll, then best roll is equal to roll, and then we're equal there. And then if so now we go through if the current roll is not set for removal, then we set it for removal. And then while the priority queue dot poll tracker that peak. So if it's less than or equal to 0, then not equal the roll that we have, pq.poll, get rid of it, and then roll tracker at pq.poll to 0, we don't have it anymore. And then equal to pq.peak. And I think if it doesn't have any issues, this should be it. But knowing me, it probably has a lot of issues. Oh wait, let's Java C prop 3, Java prop 3, and test that out. Yikes. Yeah, this is +1 because we start from position 1. This gives us the position of starting from 0, and then I think this fixes it. Roll tracker at roll is n is equal to has roll. Java prop 3. I didn't test that out. That does not look promising. Yeah, something's off here. So 212311111 212311111 3. It outputs 3 out of nowhere. And what line is this? 8. coincidentally, where we start taking, we start a second case. So I'm assuming, yeah, okay, I see. This is where it happens. We don't take input. Lol. Yeah, we didn't take input. We didn't take input for a second case. Okay, now, we should have it. Ah, no, I need to do it like this. Prob 3. Oops. That out. Okay, that looks right. This is the code. Finally, I don't know how long this took, but let's submit. Judging server is not on my side today, for real. Has me anxious, come on. Okay, I see what I did wrong. I forgot to reassign role tracker at role here. Role to has role. There we go. And this can be refactored to being just best role is equal to pq.peak. I don't know if that's faster. Yeah, it's one less if statement, right? So that was it. 100%. Let's submit the problem now. And hopefully the judging server does not forsake me. Please, judging server. Oh yeah. Alright. So that was the problem. That was Discord dilemma. We built the segment tree, and we built the query and search tools, and we were able to figure out the solution. Alright. Okay, that's it for the video, I guess. Yeah. Bye.